Hello and welcome to another one of D's ADD videos. Today we're going to be looking at a more advanced Z-score problem, normal distribution problem. Alright, so here we have a scenario in which a phone-based tech support company has its phone call lengths normally distributed, with the average call length being 18 minutes, variance of 25. So the parameters of this normal distribution is normal with 18 minutes average, and we have to square root that 25 to get the standard deviation of the population. Alright, so if we want the proportion of the calls less than 18 minutes, you should recognize that 18 is the mean. You shouldn't do any calculations at all. You should put 0.5 immediately, because by definition the mean is equal to the median. That means whenever you have a bell curve, that mean right there, there's 50% below and 50% above. Okay? That 18 value. The next one is not the mean, nor is it one standard deviation away or two standard exactly away. So you can't use an empirical rule. So what we have to do is use the Z-score equals x minus mu over sigma, and at this point we are going to set it equal to x is going to be 12 minus 18 over 5, which is a negative 6 over 5, should be negative 1.2, right? 6 divided by 5. Now we go to our Z-score, which hopefully I still have hanging around somewhere. I'm going to have to. Okay, so we check out our Z-score table, and a negative 1.2 value is what we're looking for. So we come over here, negative 1.20 is what we need, and 0 is the last column in blue there. This table can be found on my website, and that looks like it's a 0.1151. So the p-value, this is the proportion, actually let's do a different color. So the answer is in orange. The proportion that's of x less than 12 is going to be 0.1151. If you wanted greater than 12 minutes, you would just do 1 minus that value. Alright? Now the next question says if there are 36 calls, what's the proportion that calls are longer than 20 minutes? Okay, so because there's more than one call, our Z-score formula now changes to x bar, which is, or mu sub x, however your book says it, minus mu over sigma sub m, or sigma sub. Some books use sigma sub m, some books use sigma sub x, whatever it is. That denominator is just going to be sigma divided by the square root of n. That's what sigma sub n and sigma sub x both equal, is this. Alright? So the x bar is going to be the 20 minutes, that's the average of the 36 calls, minus the mean, which is still 18 minutes, and then we have over the 5, which is the standard deviation, divided by the square root of 36. So we have 5 divided by 6 on the bottom and 2 on the top. So we can flip and multiply and get 12 over 5, which is just going to be 2 and some change, 2/5, which should be about 2.4. Yeah. So then we go to our Z-score table, and we look for a positive 2.4. Notice that the values are going in opposite order now, just to confuse you. Alright, So 4 is the 1, 2, 3, 4, fifth column, the black column. So 2.4, 1, 2, 3, 4, 5 is 0.9927. So we would do 0.9927. So the p-value is 0.9927, but that's for less than. We need greater than, right? Longer than 20 minutes. So that would be 1 minus 0.9927. So 0.0073. Get the answer there. Okay, excuse me. So, if we were asked for the probability of the calls being between 16 and 20 minutes, the way it would look is like this. The mathematical question, statistical question, proportion between those two numbers. Your z-score formula is now changed to the z-score formulas that was shown up here, with the denominator changing to sigma divided by the square root of n. And when you do that, you get these two z-score values. And then when you go to your table, 2.8, you come down to 2.80 is 0.9974. So that would be for this one. And then for this one, it would be 1 minus that, which would be 0.0026. Just to confirm on your table, I just use the properties of the symmetry that the normal distribution table and graph exhibit. So if I come over here, that's what I should get on the table, and sure enough, 0.0026 is what we do get. So when you take the difference between the two, you get 0.9974 minus 0.0026, a final answer of 0.9948. Okay, and that would be your answer for that one. This last one often trips people up. It shouldn't. It says, what call length would you need for yours to be in the longest 15% of the calls? Alright, so let's just look at it conceptually. If I have a normal distribution, to be in the longest 15%, my region would have to be right over here. That means this region to the right is 0.15, and then this region to the left is 0.85. Now, what are these numbers I'm putting up? These are the proportions that we're dealing with. So, what do I have on the table? Those are the proportions less than, right? Everything you see on this z-score table is less than. So, to be in the longest 15%, you would need 85% less than. So, come over to your table and look up 85%, but now we're going to look inside here for 85, not the z-scores, the p-values. So here are the 80s, 8508 right here. Whoa, my cursed stylus is doing some funny things right now. Right there. Alright, 0.8508. Hopefully you can see it. I don't know why my stylus is deciding to misbehave, but it's 1.0, and then if I go up, I think that's 4. Wow, my whole screen is just non-responsive right now. There we are. Welcome back. Alright, finally, it highlighted the number I wanted. Now it's not going up and down. Great. My tablet's been working just fine up until now, but for some reason it's decided to misbehave. But the number, if you look up on your own, there it is, 1.004 is what you would write down for your z-score. So that would be the z-score associated with the p-value of 0.85. Alright? So, when we're doing that, if you remember, the z-score formula is this. Now we know everything but that. So let's plug and chug. Alright, so if we multiply that, we get 5 times 1.04 gives us 5.2. Then when we add 18 to both sides, there's your answer. Let's write that a little bit better. So it'd be 23.2 minutes. So your call would need to be at least this long for it to be in the top 15%. Some books have another formula that they ask you to memorize, where it's z times sigma plus mu. But that's just this formula solving for x. So I just prefer to memorize minimal amounts of stuff. There's already too much stuff out there for you to think about, so you know how to solve equations. It's not too bad to do a little multiplication, addition, subtraction. So practice, practice, practice. I hope this has cleared up things for you. Make sure that you understand the concept, because it can save you some time if you know things like mean is equal to the median. And if there's more than one sample, one observation, then the denominator changes to this, and your numerator, your mean, becomes x bar instead of just 1x. So you might even be given a bunch of data points in which you have to find the mean and find the sigma, the standard deviation, using the formulas you learned from earlier chapters. And there will be an example like that. Practice, practice, practice. Thank you, and have a nice day.